Hello everyone. So today we talk about a new chapter, that is matrices. Okay. So first of all we need to know that how these matrices are came from. Okay. How the uses of matrices actually in the higher mathematics. So whenever we came across some system of linear equation, that means a system of linear equation means like you have 2x plus 3y plus 5z equal to for let's say 4. Okay, now 4x plus 6y plus 7z equal to let's say 5. Okay, now let 5x plus 7y plus 8z equal to let's say 6. Okay, so this kind of equation you are given. Okay, now if I say you that solve this equation. Okay, so either it will be solvable or not. To check this kind of thing, there is so many equation is there which is not solvable. Okay, there is 3 equation and 3 variable is given to you, is either maybe solvable or maybe not. Okay, so for doing this, to let's checking that kind of thing, that either it is solvable or not, we use the matrices, and we also use the matrices to solving this kind of problem. Here is 3 equation, 3 variable. If there is large number of equation and large number of variables is there, like 8 variable and 8 equation is given to you, then it will be difficult to solve by the usual method that we are using in our childhood. Okay, so to get this kind of difficulties, to get rid of this kind of difficulties, we actually uses the matrices. How a matrices form? Now the coefficient of these 3 linear equations, okay, is form a matrix like this way. This is 2, this is 3, this is also this is 5, this is 4, this is 6, this is 7, and this is 5, 7 and 8. Okay, so this is called the coefficient matrix. So in this way you can form a matrices actually. So this is the basic concept, that how the matrix came from. Okay, now let's check out that what is the definition of matrix actually. Okay, so let's see, that is the basic concept of the matrix. Okay, so that is a matrix is look like this. That is, I say 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is also a matrix. Here you can see that the 8 element is there. Okay, so now first of all, something that you need to define here, that is a matrix that comes from whenever you see this kind of thing, this coefficient matrix, you always you have an idea like this way, that this has a 4 variable and 2 equation is there. Okay, if you remember this kind of thing, like the row here denoted the number of variable in a system of equation, and column is here which is denoted the number of equation given to you. Okay, so this is the main concept of this, of forming a matrix. So just this thing you need to remember here, that whenever you have face some vivas or something, that they will ask this kind of question, and it will be quite helpful for you. So now coming to the next, that is what is the definition of matrix actually. So definition, that mean we have a considering some element and arranging in the row or column wise, so it will be called a matrices. Like we can arrange some element is there, like 1, 2, 3 and -4, I say. Okay, so arranging is there, that is in various way, and the ways are having different definitions. Like this way, that is 1, 2 and 3 -4, we can arrange this in this way. Now we can also arrange this like this way, 1, 2, 3, 4. Okay, and we can also arrange this like this way, 1, 2, 3 -4. Okay, this is minus 4. Okay, so in this element we can arrange this like this way, and all those arrangement having different definitions. Like this is having a system of linear equation, having number of two unknown variable and two equation you have given. Now here is number of equation is 1, and number of variable unknown variable is 4. And here also the number of equation is 4 and the number of unknown variable is 1. Okay, so in this kind of way, in this way you can actually form a matrix. This is the main definition of the matrix. So we can say that in the word, like a rectangular arrangement of elements in rows and columns having equal number of element in each column, having equal number of element is called, in the row is called a matrix. Okay, so clearly if you have given like this way 1 2 and 3 4 5, this way, here is nothing is given to you. If 0 is given to you, then it will be a matter, but if there is nothing given to you, then it is not a matrix. This is not a matrix. Okay, but this will be a matrix here. If 0 is given here, then it will be also a matrix, but if nothing is given to you, there is blank position is here, then it will not a matrix. Now another thing you need to remember here, that is all the numbers having in the bracket is called the element. Like this, all these are elements. Okay, now one thing you need to remember here, that is order of a matrix. So what is the order of a matrix? That is matrix, if a matrix having m rows and n columns, then order of matrix is read as m by n. Okay, that is I like this way. If there is a order of a matrix like this, like you are given a matrix A, sorry, this is A, B and C. Okay, so if this matrix is given to you, now order of matrix is what? First of all, we need to count the column, and then we need to count the row here. So okay, so number of rows here, number of columns here, that is 1, and number of rows here, that is, sorry, number of column here, that is 3, and number of rows here, that is 1. Okay, so the matrix is called 3 by, sorry, not m, 3 by 1 order matrix. Okay, so this way, if this is if a matrix having m rows and n columns, okay, then m rows and n columns, okay, then the matrix is called m by n matrix. That is called that is read as m by n, and it is written as this kind of thing. Okay, that is m into n, and it is read as m by n. Okay, you need to remember that whenever you read this, you will say that m by n order matrix. Okay, now one thing that you also need to remember here, that is position of a matrix, element of a matrix. Okay, so here is a matrix is given to you, that is 1 2 3 4 5 6 7 8 9. Okay, a matrix is given to you. Now if we say that the position of 6 is what, okay, then what will be your opinion here? That is nothing but that 6 is here is, and the row number 2, okay, and the column number 3. Okay, there is in the row number 2, because 1 2, this is the row number 2, and this is column number 1 2 and 3. So this is in the 3. So the matrix element is nothing but 2, sorry, 2 by 1, this is 2, it is here, this is not 2 by, this is 2 3 element. Okay, so 2 3th element, like this way you can write this. Okay, so 6 is here 2 by 3th element, that is number of rows is you have count here, that is 2, and number of column here, that is counted 3. So this is 2 3th element. Okay, Now what about the 9 here? 9 is nothing but 3 element. Okay, so actually the matrix is written this kind of way. So now again another thing you need to remember, that is a classification of matrix. Okay, so let's see that how classification of matrix is worked. So here you can see that there is various kind of matrix, that is one is row matrix. Okay, so row matrix is nothing but the number of element arranging in a row. Okay, this is called a row matrix. Like this way, there is one row only, no column is there. Okay, so one row is here, only one row is here, is called row matrix. The column will be very different, there is 3 column, 4 column, or infinite number of column, that doesn't matter, actually it doesn't depend on the column. Okay, so now another thing, that is column matrix. Column matrix is what, there is only one column is here, there is 1 2 3 4 like this way, and no this is no row independent. Okay, so this is called column matrix. Now another thing, that is rectangular matrix. So rectangular matrix means the number of column and number of rows is not same here. Okay, where we talk about a m by n order matrix, where we can write where m is not equal to n. This is the main definition of a rectangular matrix. Rectangular matrix. Okay, so in this way we can define this rectangular matrix, like if I say that rectangular matrix is look like 1 4 7 3 0 2. Here you can see the number of rows and columns are not same, so this is called rectangular matrix. Now 0 of a null matrix, 0 or null matrix, that is the number all the element in the matrix and matrix are 0. Okay, like this way, 0 0 0 0, this is called 0 matrix or null matrix. There is only 1 0 also here, this is also called 0 matrix or null matrix. Okay, now square matrix is what? Square matrix is number of element, a number of rows and columns are same here, that is called square matrix. Square matrix is nothing but m by n matrix, where m equal to n, so this is called square matrix here. Now unit matrix, this is quite important thing. Okay, unit or identity matrix. Identity, so unit or identity matrix is nothing but the diagonal element are all 1 and all the other element are 0, that is called unit matrix. So this is nothing but 1 0 0 1, this kind of thing. Okay, another you can form, that is one, if we consider that this way, like 3 by 3 we consider, that is 1 0 0 0 1 0 and 0 0 1. So you can see that diagonal element are 1 and all the other element are 0. So this kind of matrix are called identity matrix or unit matrix. Okay, so this is the classification of matrix actually look like. Now there is some addition, there is some operation on matrices. Okay, so there is addition is here, that is called here. So whenever we came across the operation, there is in our mind there is addition, subtraction, multiplication, okay, division, this kind of thing we'll talk about. So first of all, this is addition. So matrix as addition is nothing but a usual addition, but each of the element of the first matrix and each of the element of the second matrix will be added, and it will called multiplication, like addition. So like this is a equal to, and this is look like I say that is 2 3 4 5. Okay, and b equal to I say that is 6 7 8 9. So now a plus b is nothing but 8 and 7 3 10, and it will be 4 and 8, it will be 12, and that is 3 5 and 9, that will be 14. So a plus b is look like this. Okay, all the element of the a and b will be the same here. Always remember that matrix addition will be happen, only the number of row and column will be the same in both matrices. Okay, either you cannot add it, if C is here like this way, like 1 2 3 4 and 5 6 7 8, so you cannot add it. A plus C is not possible here, like B plus C is also not possible here. Okay, so this will not be possible here because the number of the order of the A and C will not be a same here. If the order of matrices A and B will be same here, so that's why we can add those matrices. Okay, now another important thing you need to learn here, that is a multiplication of a matrix. So multiplication of a matrix by a number, if we say that is K is a scalar here, and you have a matrix that is nothing but 2 2 3 4 5. Okay, so what is the Ka will be happen, that is nothing but all that the K is multiplied with all that element, like 2k 3k 4k and 5k. So K, if K is a number like 2, then if we added this with A like 2a, then it will be added all the element in the matrix A. Okay, so it will be 4 6 8 and 10, so like this way. Now another thing you need to know about, that is negative of a matrix. So negative of a matrix, this is nothing but multiplied with -1. Okay, multiplied with -1. So this is nothing but all the element of the matrix will be negative here, then it will be -a. Okay, so another thing, that is subtraction. Subtraction is nothing but actually only you can say that is the unlike addition, like addition. Okay, this is completely like addition and nothing is more important like that. So I can say that is A minus B equal to, you can write this like this way also, A plus minus B. Okay, if you taking the negative of B and you will add, then it will be same as the addition. Okay, so that's all for today. We'll see the multiplication of the two matrices. That will be quite interesting and something that you need to learn about. So this will be in the next session. And also we talk about the transpose of a matrix, and we finding the order of a matrix when two matrices are multiplied, this kind of thing. So one lecture will be needed for the rest of the theory, and then we'll starting the some problems with matrices, and this chapter will be done. So that's all for today. We'll see you in the next session.